The declared goals of our project are the discovery of the real mission thread path, monitoring user experience, following transactions end-to-end, examining the details of application server processing, and finally, interlayer forensics correlation. In the following slides, we present an example which demonstrates some of our achievements over the first half year of the project. Note that the mission thread path complexity may vary significantly. Here we've started from a relatively simple but very common scenario in which we managed to achieve a decent level of detail and good representation of the monitored data. Let's demonstrate this scenario as well as the deployed AFF solution, the AFF components, and the results of the monitoring. In the given example, the client application submits a request to the Java-based application server, which has a web service deployed. In order to process the request, the web service performs a database call, returns, and creates a response for the client. Therefore, the network in the given scenario contains two segments, one from the client to the application server, and one from the application server to the database. To monitor the transaction path, AFF uses two components, the reflector and the collector. The AFF reflector allows us to listen in on network traffic and is therefore used to inspect both of the network segments. The rest of the processing is done on the application server. This segment is monitored by the AFF collector. The collector gives us the detailed information about the call stack execution in the application server. Now let's take a look at the results of the monitoring. The AFF reflector is a program module that's used to discover and monitor network-based resources. Information collected by the reflector can be used in various ways. For example, it allows us to create a map which shows how the network-based resources communicate with each other. This particular map shows us that the given host is the client of another host and that they both communicate using the SOAP protocol. This host in the center is also a client of the JDBC host, and it requests data using the JDBC protocol, as we can see here. Reflector also displays the data that was sent over the network during the processing of a given transaction, as well as some complementary information available from the transport layer. Here we can see that in the case of the text-based protocols, we can access the complete information, which includes the method name and content of the request, as well as the response. We can also extract the timing information. For certain text-based protocols, like HTTP and SOAP, we can also get some additional details. The results of the monitoring can be invaluable when troubleshooting various real-life application and configuration problems. The AFF framework monitors the execution of an application on an application server with the help of AFF collector. Collector is an agent for monitoring the way requests are processed in the servers of a distributed application. Let's see what data we can gather. After analyzing collected data, we can see operational information about the way that requests submitted to the application's server were processed. Here we can see that only one request was made for this example, and the protocol of the request is SOAP. Here we can see information pertaining to the processor usage and the time taken to complete the requests. On top of this, we can view information about the environment. Further, the information gets more and more detailed as we can trace the call tree starting from the very first call traced by the collector. Let's drill down to the information related to this particular transaction, which is even more interesting. We can access information about its environment and thread. On top of this, we can view the parameters of the calls. Next, we can see the full chain of execution, and in particular, we can see this call to the database. Note that we can view the exact SQL query that was used to make the call. Finally, I would like to note that this call tree does not give us complete information about the requests, but is limited only to the calls made within the application server. And now we present one of the most interesting concepts, end-to-end mission thread monitoring. As we can see, one instance of a transaction was processed in our test system. The overall real user experience has been recorded by the reflector. On top of this, the entire transaction path has been recorded and reconstructed step by step. The network portions have been reconstructed by the reflector, and the processing on the application server has been reconstructed by the collector. We can easily recognize the end-user request, web service portion, and the subsequent database call. We can see the order in which the processing was done, as well as all the network delays and the time when the monitored application calls were made. From here, we can also navigate to the results of the monitoring produced by the reflector and collector modules, which allow for a more complete analysis of the behavior of our applications and application servers. Thank you.